Hi, fifth period. I'm making this video lesson today because sadly I'm not there with you guys right now. Hopefully you guys treat that substitute nicely. At least leave a good impression for me, please. I'm making this video because rather than waste this day, I want to make sure that we keep right on track with you guys, even though I'm not there. Because like you guys said you wanted, I wouldn't mind having a movie-free day either. So hopefully, if we get this lesson done and you guys don't need too much help from me, hopefully this video is enough, then we'll stay right on track. And I think we're going to have that free day we're looking for. So without further ado, as always, anytime you watch a YouTube video or any video in general, remember, you have the ability to fast forward. So if my lesson's going well and you understand it pretty quickly, skip around, watch it on fast forward. If something doesn't make sense, rewind, watch something again. You have the power. That being said, we're going to cover four things. Four things we need to make sure that you open up today. If you're in class, it's going to be all on the podium where you usually find all my handouts. If you're on Google Classroom, then you're just going to open them in the usual places. Those four things are going to be our warm-up, our quiz, our notes, and our homework. So sadly, yes, we have a quiz today. But as usual, I'm going to have us do a warm-up, and hopefully, and from what I saw in the past classes, the warm-up is really close to what this quiz looks like. So when we go over it, you'll be fine. Everything else, like the notes, the homework, I think the lesson should be enough because it's not too difficult of a topic. So without further ado, we're going to start with the warm-up section. So, taking a look at our warm-up, it's a series of polynomials in different arrangements. We have them dividing polynomials, we have them multiplying polynomials. This is everything that we did from last class where we used all our rules. So here's what I suggest. Break out those notes, break out that formula sheet that I gave you guys of all the exponent rules from that we ripped off from the packet. See if you can pause the video, solve this warm-up yourself first, because as always, trying to do it yourself will make it much easier to do the quiz. Okay, I'm going to assume that you've unpaused, you've tried them out, did your best, and I'm going to work these out. And as you follow along, hopefully you got most of these right. If not, maybe this will help out. So the first thing we need to look at is we have this division of a polynomial on top and a division of, well, actually, it's not even a polynomial. It's a division of a term and a division of a term, and we have a -3 as an exponent, so to the -3rd power on the outside. Remember, anytime we have a negative exponent, all that's going to do is flip things around, and if I have an exponent, negative or positive, on the outside parentheses of a fraction, then I know that's going to go to the top, and I know that's going to go to the bottom. My recommendation, hopefully you solved and simplified what's on the inside first, because that's just going to make your life easier. So I'm going to do it that way. If you didn't, that's okay, but hopefully you did. No matter what, we should end up at the same solution, even if you went from outside in first. So we have, simplifying the inside of this fraction, -6 over 30. I think that simplifies to, here, let's do this in blue. -6 over 30 is going to simplify to -1/5, I believe. 6 divided by 6 is 1, 30 divided by 6 is 5, yeah. So I know all of this is going to be 1 times a bunch of stuff, so I don't really need that 1. I just know it's going to be negative something on top. I have x squared divided by x to the 5th. Dividing, our rule says we should subtract the exponents, so 2 minus 5 is -3. X to the -3rd, if it's a negative exponent, we put it on the bottom. So this is going to be x to the +3rd on the bottom now. Y cubed divided by y, that's 3 minus 1, because there is a hidden 1 here, y to the 1st power. If there is no exponent, there's a hidden 1. 3 minus 1 is 2, so y squared. We have y squared on top. We leave it on top because it was not a negative exponent. Z divided by z, I think just cancels to 1. So it's a good thing we're simplifying, because now I don't even have to deal with that z variable. So I don't need all this extra fraction line. And it's just going to be this, all of it, raised to the negative third power. So our rule says that if I have an exponent on the outside of a parentheses fraction, that exponent will go to the numerator and the denominator. So let's do that. This is going to be, let's see. This is going to be, let's separate this negative into its own number, just to recognize that negative to the third power. So negative times negative times negative will give us a negative. So we're going to assume that and have this be negative y squared, the whole thing to the negative third, over 5x cubed, the whole thing to the negative third. And all I have to do, since this is negative exponent, I just flip both of them from top to bottom, bottom to top. And that'll give us 5x cubed on top over negative y squared cube on bottom. And power to a power, this cube goes to both the 5 and the x cubed. So that's going to be 5 cubed and x cubed over, let's see, that negative 1, I'm not going to write it, but if I distribute this third power to both y squared, so that'd be y squared cubed, and all I know is that this negative is going to stay, because negative times negative is positive, times one more negative is back to negative. So we're going to have the negative out front, and y squared cubed. Okay. So, solving this all out, I think 5 times 5 is 25, times 5, I believe, is 125. Pretty sure. 5 cubed is 125. X cubed, power to a power rule, that's 3 times 3, so x to the 9th. And then negative out front, y squared cubed, that's going to be 2 times 3, or y to the 6th. And there's our answer. Okay, moving on to the next one, we have 5xy squared z times 2x squared y cubed, but we have all of this to the third power. So let's solve that third power first. So power to a power, this is going to be cube goes to every base, to the 2, to the x squared, and to the y cubed. So 2 cubed, x squared cubed, times y cubed, oops, my bad, x squared cubed, there we go, and y cubed cubed. So 2 cubed, 2 times 2 is 4, times 2 is 8, x squared cubed, power to a power, multiply, 2 times 3 is 6, y cubed will give me y to the 9th, multiply this by my 5x y squared z, and we get, let's see, 5 times 8 is 40. X times x to the 6th is x to the 7th. Y squared times y to the 9th is y to the 11th. And z just tags along. Very cool. Next up. Okay, I have a binomial. So this is one term. This is the other term. So 2 terms makes a binomial times another binomial. Binomial distribution, we just use FOIL. So first, outer, inner, last. Let's do this in green. So first is 4x squared y times 3xy. That's going to give us 4 times 3 is 12. X squared times x is x cubed. Y times y is y squared. So that's first. Outer is 4x squared y times negative 4y to the 5th. And I believe that'll give us positive times negative is a negative. 4 times 4 is 16. X squared. And then y times y to the 5th is y to the 6th. So that's outer. Let's do inner now. Negative 6x times 3xy. So negative times positive is negative. 6 times 3 is 18. X times x is x squared. Y tags along. And finally, first outer inner last. So that's going to be negative 6x times negative 4y to the fifth. Negative times negative is positive, so that'll give us 24. 6 times 4 is 24. Xy to the fifth. And now I check, are any of these like terms? I don't think so, because this is x cubed y squared. There's nothing else that's x cubed y squared. This is x squared y to the sixth. I think that's its only one. X squared y and xy to the fifth. So these are all different terms, not like terms. Cannot combine them. I'm done. There's my answer. And then, let's see. Oops, I think I might have erased this. But this is 9x squared plus 8x minus, parentheses, 6x squared minus x plus 2. This should be the easiest one, because the only thing we really have to do is distribute this negative to every term. And we get negative 6x squared. Negative times negative, so positive x minus 2. And I'm just going to combine like terms now. So 9x squared plus 8x minus 10. And then let's see. I should have 9x squared and minus 6x squared. That's going to give us something. 8x and x will give us something. And negative 10 and negative 2 will give us something. So 9x squared minus 6x squared is 3x squared. 8x plus x is 9x. And negative 10 minus 2 is negative 12. And we are done. So here are all our answers. If you need to pause the video and check your work one more time, I'll leave this up. Okay, so we're done with the warm-up. Have the warm-up with you. Use the warm-up, use your notes, use the formula sheet. I think you can take your quiz now. You have it with you. This is the only part of the day where I ask, work individually. You have your notes, you have your warm-up, you have everything you need. Take this quiz on your own. Make sure you do it quietly so the sub doesn't get annoyed. And once you're finished with the quiz, take the quiz and put it on my front desk, the place where I usually sit at the front of the classroom near the projector screen, and make a neat pile for me. So once you're done with the quiz, done with that, move on and finish this video, unpause, and go to the lesson notes section, starting now. So, lesson notes. Today, we are talking about dividing polynomials. So if you need to take a break now, take a break. You have plenty of time. This isn't very hard of a lesson. And the only thing is, if you get done early, maybe you can finish the homework before class ends. So dividing polynomials, we have 6x to the fourth y cubed plus 12x cubed y squared minus 18x squared y, and we're dividing it by 3xy. So anytime I have a division and whatever was on top, my numerator, is multiple terms. So 1 term, 2 term, 3 term. We know they're terms because they're separated by positive and they're separated by minus. All I do is split it up. So each term, each original term up here, I split them up into 3 parts and divide them individually. And I should get an answer. So 6x to the fourth y cubed divided by 3xy. 6 divided by 3 reduces to 2. X to the fourth divided by x. Remember our rule. If I divide like bases with exponents, I subtract the exponents. So this is 4 minus the hidden 1, which is x cubed. Y cubed divided by y is y squared. Plus 12 divided by 3 gives us 4. X cubed over x gives us x squared. Y squared divided by y gives us y. Minus 18 divided by 3 is 6. X squared over x gives us x. And y over y, 1 minus 1 is 0. So this cancels to just y to the 0, which we know is 1. So it disappears. That's the real reason why y over y becomes 1. So it's gone. Hopefully we got this and that isn't too much trouble. I'm going to let you try the next one on your own. So pause the video, try it. Unpause. Hopefully you got it. Let me work it out with you. 20 over 4 is 5. C to the 4th over C gives me C cubed. D squared over D gives me D. F over F cancels to 1. Minus 16 divided by 4 is 4. C divided by C cancels to nothing. D over D cancels to nothing. F squared over F gives me F. Plus, let's see, 4CDF divided by 4CDF. I don't even need to go through the whole thing. It's something divided by itself. That'll just give us 1. And we're done. Moving on, we have long division. So the whole point behind today's lesson is that when we divide polynomials, so up here, we only divided by a monomial, 3xy, or 4CDF. It's a polynomial if it's something like x minus 5. So this is one term, this is two terms. So 2 terms is more than 1. That makes it a polynomial. So x minus 5, we're dividing by x minus 3. The way we do these is with long division. So before I get into how to do that, let's see if we can practice and remember the algorithm for long division. So we learn that if I'm given 4,864 and I'm dividing it by 4, if I want to do it on paper without a calculator or not in my head, I could do this using the long division algorithm method. So put it in this shape and we tell ourselves, well, I think 48 is the biggest number so far that I can put 4 into, that I'm definitely sure about. But if I am not sure about 48, I could always start with 4. So 4 goes into 4 one time. So 4 times 4 is, 4 times 1 is 4. We subtract these amounts to get 4 minus 4 is 0. Bring down the 8. How many times does 4 go into 8? It goes 2 times. And the nice thing is that 4 times 2 is 8. The subtracts gives us 0. Bring down the 6. If we wanted to just jump ahead and say, how many times does 4 go into 48? Well, it turns out 4 times 12 gives us 48. That's why we ended up with a 0. Moving on, how many times does 4 go into 6? It goes 1 time. Bring down 4 times 1 is 4. Subtract 6 minus 4 is 2. Bring down our 4, and we have how many times does 4 go into 24? It goes 6 times. And this is going to divide evenly. So 4 times 6 is 24. If we subtract these amounts, we get 0. So there is no remainder. Our answer means that 4 times 1,216 gives us 4,864. Okay. If you remember how to do the long division algorithm, try 123 divided by 5. Pause the video. All right, let's do it together. How many times does 5 go into 1? Well, it doesn't. So we move on. How many times does 5 go into 12? It goes 2 times. 5 times 2 is 10. So that's going to subtract these. 12 minus 10 is 2. Bring down to 3. How many times does 5 go into 23? It only goes 4 times, but 4 times 5 is 20. If I subtract these, I have 3. So I think most of you know that I could keep going and say, well, let's just add in this 0.0, bring it down, and then keep solving. Eventually, we would know that this is the full answer. 123 divided by 5 is 24.6, right? If I did that 0 bring down. But for now, let's not do that. Back when we were in 3rd, 4th grade, what we would do is we would say our answer is 24, remainder 3. And we know remainder 3 isn't actually how much is left over, because we know the answer is 0.6. We get 0.6 because the real number that we tack on at the end is our remainder divided by the dividend. So that would be 3 divided by 5, which is 0.6. But go ahead and just leave our answers as 24 remainder 3. We're going to keep doing that because when we divide some of these polynomials, we're going to have a remainder sometimes. They won't divide evenly. That says a couple of things, and the day after, when I'm actually in class, we're going to talk about what it means when we have that remainder. So go ahead and write it like that for now. Moving on to actual polynomial division. It's polynomial division because I'm taking, this is a 3-term polynomial divided by a 2-term polynomial division. The easiest way to do this is using long division. So the way I go about it is this. I see that I have x minus 5 as my divisor, and x squared plus 3x minus 40 is my dividend. So that means, how many times does x go into x squared? That's a weird way to ask that, but the way I answer is, x times what gives me x squared? Well, x times x gives me x squared. So if I multiply x times x minus 5. So I'm not going to write this every time, but what's happening is I'm multiplying this number I'm getting up top here that I'm choosing and multiplying it again and again and again by my divisor. So x times x is x squared, x times negative 5 is negative 5x. So that's going to give me x times x minus 5 is x squared minus 5x. Now, remember up here, we did that. We did that plenty of times. We had 1 times 4 gave us 4, and then we subtracted. And we have to be careful. When I subtract this, I'm subtracting all of it. So this is going to change our signs. If you can keep the negative straight in your head, then you don't have to rewrite this. But for now, know that this is the negative on the outside of the parentheses would make this negative x. So that becomes negative x. And the negative distributes to make this positive 5x. So we get x squared minus x squared cancels to 0. 3x plus 5x is 8x. So I'm going to keep doing that multiple times, but I'm not going to show that distribution of the negative every time. Hopefully you can keep that straight in your head. So we subtracted. Now we bring down what's left over, just like we do in normal long division. How many times does x go into 8x? Well, x times 8 gives me 8x. So we say plus 8. 8 times x minus 5 would give us 8x minus 8 times 5 is 40. Well, huzzah. I subtract something from itself, I'll get a remainder of 0. What this means is, a remainder of 0 means this divided evenly. This means in polynomial terms that x squared plus 3x minus 40 is factorable because these are its factors. X minus 5, x plus 8. So if I wanted to, I could say x minus 5, parentheses, x plus 8. If I did FOIL, I would obviously get back this original answer here, x squared plus 3x minus 40. I'm not asking you to do that, but if you ever needed to check your work, that's one way you could. So, let's see. I think we should do this one together. So if you want to try ahead, pause, unpause. Here's the answer. X squared plus 7x minus 30. So I ask myself, how many times does x go into x squared? Well, x times x gives me x squared. And then x times x minus 3 would give me x squared minus 3x. I'm going to subtract all of this. So that's going to give me x squared minus x squared cancels to 0. 7x negative makes this positive. So 7x plus 3x is 10x. And how many times, oh, forgot to bring out the negative 30. How many times does x go into 10x? Well, x times positive 10 gives me 10x. So that's going to give me 10 times x minus 3 is 10x minus 30. Subtract this all the way through, and we get 0. So that means x squared plus 7x minus 30 is factorable, and its factors are x minus 3 and x plus 10. But if I was just looking for the quotient, it's x plus 10. Next, Sometimes, and I think this might be one, where if I divide by a trinomial, it's going to look a little different, but the process is still the same. I still ask myself, how many times does x squared, the first term, or the biggest index term, so this is squared, so that's the one we look at. How many times does x squared go into x cubed? So I say x squared times just x would give me x cubed. So if I multiply x times x squared minus 5x plus 6, I get x times x squared is x cubed. X times negative 5x is negative 5x squared. And x times 6 gives me positive 6x. I'm going to subtract this whole thing. And we get x cubed minus x cubed gives me 0. Negative 2x squared minus minus becomes positive. So negative 2x squared plus 5x squared. So 5 minus 2 is positive 3x squared. And then negative makes this a negative 6x. So negative 9x minus 6x is minus 15x. Bring down my 18, my positive 18. And how many times does x squared go into 3x squared? Well, that's just going to be plus 3. So 3 times x squared is 3x squared. 3 times negative 5x is minus 15x. And 3 times 6 is 18. Subtract this entire thing. Something subtracted by itself gives me 0. So this is factorable. We have no remainder. My quotient, or answer to this division, is x plus 3. And that just means that this trinomial, x squared minus 5x plus 6, multiplied by x plus 3, would give us back this x cubed minus 2x squared minus 9x plus 18. So I think this one is the example where you're going to have a remainder. So if you want, try it on your own. Pause the video. Okay, unpause. Let's see what we get. I have x squared. How many times does x squared go into x to the 4th? Well, x squared times x squared would give me x to the 4th. So x squared times x squared would give me x to the 4th. X squared times x would give me x cubed. And x squared times minus 2 would give me minus 2x squared. So I subtract this whole thing, and I get these cancel, and negative 6x squared minus minus becomes positive, so minus 6x squared plus 2x squared is minus 4x squared. Bring down both of these now, so I need to bring down the whole thing. So minus 4x plus 14. So what the trick is, we need to bring down whatever's left over. In the cases here, it was always just bringing down one thing, or bringing down one thing. But here we need to bring down both. So how many times does x squared go into negative 4x squared? Well, x squared times negative 4 would give me negative 4x squared. So negative 4 times x squared would give me negative 4x squared. Negative 4 times x is negative 4x. And negative 4 times negative 2 gives me positive 8. Subtract both of these, and I think we should get some cancellation. So this cancels, and 14 minus 8 gives me 5, 8, 9, 10, 11, 12, 13, 14. Nope, 6. Never mind. 14 minus 8 gives me 6. So that means I have a remainder. I don't know what that remainder is yet. We're going to talk about that another lesson day. So for now, we're going to say my answer is x squared minus 4, remainder 6, and we're done. So here is my answer here. X squared minus 4, remainder 6. Eventually, we're going to talk about what that number really means, but not today. Okay, now we're going to work on this next problem. we have m to the fourth minus 3m squared minus 18 divided by m minus 2. So the reason I have this example here is because originally I have x cubed, x squared, x to the first power, and no x. I have x to the fourth, x cubed, x squared, x to the first power, no x. So here, if I'm having this be my dividend, then it's m to the fourth, and I'm skipping m cubed and going straight to m squared. So there is nothing m cubed. The problem is when we do long division, that doesn't play nice when we're adding and subtracting top to bottom. So we need placeholders to have all of this make sense. So let's move off to the side here. So we're going to need a lot of space to do this one. So let's have m to the fourth. We're still starting with that. But between m to the fourth and m squared, there's an m cubed. But since this says there is no m cubed, let's just add 0 m cubed, which is still nothing, but it's a good placeholder. And then I have my minus 3m squared. And then between m squared and negative 18, there's something with just an m. But since this is telling me that there is no something m, I just add 0m as a placeholder, minus 18. And you're going to see pretty soon why we're doing that when we're adding and subtracting, why we need that. So we're dividing m minus 2. So how many times does m go into m to the fourth? That's just going to be m cubed. M cubed times m gives me m to the fourth. Multiply m cubed by m minus 2, we get m to the fourth minus 2m cubed. Subtract all of this, and take a look. I have 0m cubed on top of negative 2m cubed. That helps. That way I can combine like terms when I subtract down. Whereas if negative 3m squared was on top, I wouldn't be able to do that. So the placeholder helps. So subtracting negative m to the fourth, this cancels to 0, and then 0m cubed plus 2m cubed is just positive 2m cubed. How many times does m go into 2m cubed? M times 2m squared gives me 2m cubed. And don't forget to bring down our next term, so negative 3m squared. So we have 2m squared times m minus 2 will give us 2m cubed minus 4m squared. Subtract all of this, and we get 2m cubed minus 2m cubed cancels to 0. Negative 3m squared plus 4m squared gives me m squared. Yes. Bring down my 0m, so plus 0m. How many times does m go into m squared? It goes m times. M times m minus 2 gives us m squared minus 2m. Subtract all of this, and we get m squared minus m squared cancels. 0 plus 2m gives me positive 2m. And bring down my minus 18. How many times does m go into 2m? It only goes positive 2 times. So 2 times m minus 2 gives me 2m minus 4. Subtract all of this, and we get 2m's cancel. Negative 18 plus 4 is negative 14. So there's our remainder. There's nothing left I could divide up here. Nothing left I could bring down. M doesn't go into negative 14. I have my answer, and I have my remainder of negative 14. And like I said, we just write our answer like this because next lesson we're going to talk about what that remainder really is. So the next step of this, thankfully, is just shortcuts. So mathematicians are very, very lazy. So we've developed synthetic division. There is a proper name for this, the Horner-Ravini method, something like that, but most just call it synthetic division. What we do is we start by drawing an upside down division symbol, just so that I make it very clear that I'm doing synthetic division and not actual division. And what we do is, to make our lives easier and shortcut, I take the coefficients of my dividends. So that's going to be 2, negative 13, 26, negative 24. And I'm going to put those underneath my division symbol. And that's just going to make things a little simpler to cut down. We're cutting away a lot of the excess. And the only other step we need to do, take what my divisor, x minus 4, and to find out what I'm going to write here on the outside, it's not going to be x minus 4. I'm going to take x minus 4, set it equal to 0, solve for x. So x minus 4 equals 0, add 4 to both sides, x equals 4. This is what we're going to put on the outside. So we're synthetically dividing by 4. And it's an algorithm. There is a proof for this. I highly doubt you want to see it. If you do, I don't mind showing you sometime out of class. But for now, follow with me. It's just an algorithm that works and is a shortcut. So there's nothing I can do with the 2. I bring it down first. And then that's usually the first step. Actually, always the first step. Bring down the first number. Next, I take 4 and multiply it by 2 to give us 8. And then I add these two numbers. So negative 13 plus 8 gives me negative 5, 8, 9, 10, 11, 12, 13. Yes, negative 5. 4 times negative 5, so multiplying 4 times negative 5 gives me negative 20. Add these numbers. 26 minus 20 gives me 6. Oops. And then 4 times 6 gives me 24. Add these numbers. Negative 24 plus 24 gives me 0. So this 0 at the end here means no remainder. I've solved it. It's factorable. And the way I interpret this information, 2 negative 5, 6, is by saying, well, x cubed divided by x would give us x squared. So I know this represents 2x squared minus 5x plus 6. And there's my answer. So one day, if you're very curious, I can explain why this works. But for now, it's better if we just use this as a shortcut method. And sort of in the same way why we just understand that this long division method just fits. It works. There's a proof for it. I don't think you want to see it, unless you really want to. So try this one using that same method. Remember, if there is a variable missing, so this is x to the 4th, skipped x cubed to x squared, we need to put a placeholder there. I think that's the only placeholder we need, but that should help. So I'm going to set us up. We have the coefficients of 4. There is no x cubed, so I need to put a 0 there. So let's pretend there's a 0x cubed in between here. So 4, 0, 2, negative 4, and finally 12. Those are going to be our coefficients. Set it up as 4, 0, 2, negative 4, and 12. And I take x plus 2, set it equal to 0, solve for x, so minus 2 on both sides, and x equals negative 2. That's what I'm going to synthetically divide by. It works. It makes all of these check out. So pause if you want to try this on your own. On pause, we have bring down the first number. That's always the first step. Negative 2 times 4 gives me negative 8. 0 minus 8 gives me negative 8. Negative 2 times negative 8 gives me positive 16. 2 plus 16 gives me 18. Negative 2 times 18 gives me negative 36. Negative 4 minus 36 gives me negative 40. Negative 2 times negative 40 gives me positive 80. And 80 plus 12 gives me 92. So I didn't end on a 0, so this means this wasn't factorable. I have a remainder, 92. But I interpret all of these numbers by saying x to the fourth divided by x would give me x cubed. So I'm going to have 4x cubed minus 8x squared plus 18x minus 40, remainder 92. And there's my answer. So, using a combination of synthetic division and long division that we did up here, you should be able to do your homework. When we do this on quizzes or tests, usually if I get a polynomial division problem, I'm going to give you the option either do long division or do synthetic division, because 90% of the time you're going to like one or the other. I personally think synthetic division is perfectly fine and it speeds up the process for me. But for some of us, doing long division just makes more sense, and that's okay. You don't really save or waste too much time, so either works. That should be all. If you have any questions, I'm actually downstairs on near the atrium, near the entrance. So I'm still here at school. I'm just doing training. So if you really have a question, send me an email. I still see them. Or see me after school, because I'm still going to be here at school teaching. Okay? Have a good day. Hopefully you guys get all your stuff done, because next time you see me, it's just going to be review day and one little lesson where we talk about what that remainder means, what that really means. And if I cover that and give you the review, I think I'm going to see you guys Friday. Then we can have our movie day, hopefully. So, see you guys then.